Hello everyone, welcome back to Sermon SAT Prep. Today we're tackling the final chapter of the College Panda math book, which is chapter 27 of volume. So let's go over all of those questions. Question 1. In the figure above, a cylindrical block of wood is sliced into two pieces as shown by the dashed curve. What is the volume of the top piece in cubic centimeters? So if you look here, we can kind of see that each of the pieces are half the cylinder, right? Because it's cut into half and sliced into two pieces. So basically, it's 1/2 of the volume of cylinder, which is pi r squared h. And this will give us 1/2 times pi times the radius is 4, right? Because it should be half of 4 centimeters, so it's 2 squared times 5. And that'll give us 10 pi, which means A is correct. James wants to cover a rectangular box with wrapping paper. The box has a square base with an area of 25 square inches. The volume of the box is 100 cubic meters. How many square inches of wrapping paper will James need to exactly cover all faces of the box, including the top and the bottom? So let's first calculate the height of the box, and we can calculate the height by dividing the volume by the area of the base, right? So the volume is 100 cubic meters, and we divide it by the base, which is 25, and we get 4 as the height. So our value for the height is 4, and because the square base has an area of 25, and because it's a square, all the sides are the same. 2x is equal to 25. X times x is equal to 25. So and x has to be the same number as this x and this x. So it must be 5 times 5, which will give us 25. So x is 5. So we know that if we were to draw this rectangular box in 3 dimensions, we'll get something like this, where this is 5, this is also 5, and the height is 4. So this is the dimension of the box, and the top and bottom have a surface area, right? The surface area is 2 times 5 times 5, so 2 of the squares, and that'll give us 50. And the front and back will also have a surface area. The front and back instead will have a surface area of 5 times 4, right? Which will give us 40. And again, we can do the same for the left and right side. So this side, and if you draw it here, this side, and that'll also be 2 times 5 times 4, which is also 40. And to find the inches of wrapping paper that will be needed to cover all the faces, we're just simply wanting to calculate the surface area, right? So the surface area is just the addition of all those faces. So it's 50 plus 40 plus 40, which gives us 130. So the answer is B. What is the volume of a cube with surface area 24a squared? To solve this question, let's first let's set a value to determine the side of the cube. And because we don't know the side, we can just call it x. And because we know that the cube has 6 faces, right, and the area of each face is just x times x, which is x squared, we can express the volume of a cube as 6x squared. And that is equal to the volume, which we're given, 24a squared. Now we can divide both sides by 6 to get x squared is equal to 4a squared. And then root both sides to get x is equal to 2a. So the volume is just x to the power of 3, right? To find the volume, we just multiply the sides by the side and the side and the side for a cube. So that is the same as substituting 2a for x, which will give us 8a cubed. So the answer is C. Okay, a cylindrical water tank with a base radius of 4 feet and a height of 6 feet can be filled in 3 hours. So cylindrical water tank, so the radius is 4 and the height is 6. And this can be filled in 3 hours. At that rate, how many hours will it take to fill a cylindrical water tank with a base radius of 6 and a height of 8? Okay, so The cylindrical tank can be filled in 3 hours, right? So let's calculate the volume of that cylindrical tank first. So remember that the volume, to calculate the volume, the cylindrical tank is always pi r squared h, which in our case is pi times 4 times 4, which is 16, times 6, which will give us 96. So that's 96 pi. And we can do the same with the other values that were given. So we get pi times 36 times 8. No, it's 36 because it's 6 times 6. And that will give us 4, 2, 7, it's 288. So 288 pi. So now we can use the first tank information as a conversion factor. So we have 288 pi times we set fraction, and the denominator is obviously the 96 pi, which is the volume, and the numerator will be how many hours it took to fill that tank, which is 3 hours. Now we can just put this in a calculator, and we should be getting 9 hours. So the answer is D. Okay, let's move on to question 5. A container in the shape of a right circular cylinder shown above is just large enough to fit 3 exact tennis balls with a radius of 2 filled to the top. If the container were emptied out and filled to the top with water, what would the volume of water in cubic inches held by the container? So this is basically just asking us for the volume of the cylinder, right? Because if the water is filled to the top, and that's the volume of the water, because it's filled to the top, it's just the volume of the cylinder. And we know that the base, the radius of the base is 2, right? We're given that. And we know that the dimensions of each tennis ball should be, the diameter should be 4, right? Because it's just the radius times 2. So the height of the cylinder is just 4 times 3 because there are 3 balls, so it's 12. And once again, we know that the volume for a cylinder is pi r squared h. So in our case, it's pi times 2 squared times 12, which will give us 48 pi. So the answer is D. Okay, an aquarium has an 80-inch and by 25-inch rectangular base with a height of 30 inches. The aquarium is filled with water to a depth of 20 inches. If a solid block with a volume of 5,000 inches cubed is completely submerged in the aquarium, by how many inches does the water level rise? So the way to solve this problem is to pretend that the block, let's say the block is poured into the aquarium, right? So we have to determine how high would the level of that liquid rise. So to do that first, we can first express it in terms of the volume. So the volume is just the length times width times height because it's a rectangle, right? And we know that the volume, we just plug in the values that we know. So we know that the volume is 5,000. We know that the length is 80, right? And the width is 25. And we have the height. So all we have to do now is we can solve for h. So we have 5,000 divided by 80 times 25, and that's h. And if you put this in a calculator, we should be getting 2.5. So the answer is 2.5. Question 7. A cube with a side length of 5 inches is painted black on all 6 faces. The entire cube is then cut into smaller cubes with a side of 1 inch. How many small cubes do not have any black paint on them? So let's first sketch this. So we have a cube with side lengths of 5 inches painted on all 6, painted black on all 6 faces, right? So if we take away all the cubes with black paint on them, then we essentially have a smaller cube, right? And this smaller cube has a side length of 3, right? And because for the volume, it's just the same side and cubed. We can just write as 3 cubed, which will be 27 cubes that are not painted black. So the answer is 27. Okay. Question 8, Una finds a box with an open top. Each side is 8 inches long. If she fills the box with identical 2 inches by 2 inches by 2 inches cubes, how many of these cubes will be touching the box? So we know that each small cube is 2 by 2 by 2. So the volume of each cube is 2 cubed, which is 8. So the volume is 8. And the volume of the outer box is, because each side is 8 inches long, it's 8 cubed, which is 512. So to calculate how many boxes there are in how many cubes there are in the box, we can just divide the volume of the bigger outer box with the smaller cube. So it's 512 divided by 8, which will give us 64 cubes in the box. And if you take away all the cubes that touches the box, right, then we have, like, again, like for the previous problem, we have another smaller rectangular box, right? But since we are just removing those that touch the box, the new square base that is smaller than the original base would have a side of 4 and a height of 6, right? So the volume of this inner box would just be, because both sides of here is 4 times 4 times 6, which will give us 96. And we know that because each cube has a volume of 8, we can just divide the 96 by 8 to get 12, which means there are 12 cubes that are not touching the box, right? So to figure out how many cubes are actually touching, we subtract it by the total number of cubes that we have, which will give us 52. So there are 52 cubes that are touching, right? So the answer is 52. Okay, a 3 by 4 by 5 solid block is made up of 1 by 1 by 1 unit cubes. The outside surface of the block is painted black. How many unit cubes have exactly one face painted black? So if we were to draw this solid block, like so, and let's say this is 5, let's say this is 3, and this is 4. The outside of the surface of the block is painted black, right? So that means that the only cubes that have exactly one face painted black would be the ones in the middle of each side, right? So it would be 3, 1 here. In this case, it will be the 2, 1. And the top will be, and the top has 3 times 2, so it will be 6 cubes at the top. So we have 3 plus 2 plus 6, which means we have 11 of these boxes. And because that's what we did for the top side and the front side, we still have to consider the back, the left, and the bottom. So we just multiply this value by 2, and we'll get 22. Question 10, a food manufacturer produces packages of frozen ice cream cones. Each ice cream cone contains a right circular cone that is filled with ice cream until a hemisphere is formed above the cone as shown in the figure above. The right circular cone has a base radius of 9 and a slant height of 15. What is the volume of ice cream in cubic centimeters the manufacturer uses for each ice cream cone? So the thing we notice here is, since we're given a slant height, what we need to do is kind of form a right triangle if you can. And the way we do this is by drawing a line in the middle, and now we have a right triangle. And if you look here, we can kind of see that this kind of aligns with the patterns of a common right triangle, like 3, 4, 5, for example, right? And if we know that mnemonic, we know that the height will be 12. Or otherwise, we can also use the Pythagoras theorem, but this is the shorter way to kind of solve these problems. So we know that the height is 12. So good. So now we know the height of the cone. And to find the volume of ice cream, it must be the total volume, which means we have to find the volume of the cone. We have to add it to the volume of the hemisphere, right? So volume of a cone is 1 over 3 times pi r squared h, plus the hemisphere is 1 over 2 times 4 over 3 pi r cubed. The reason why it's 1 over 2 is because it's cut in half, right? It's because it's a hemisphere. And now we can just simply plug in the values that we know. So the radius of the cone is 9. And the height is, like we found before, is 12. Plus 1 over 2, 4 over 3, pi 9 cubed. And we can put this in a calculator. And we should get 324 pi plus 486 pi, which is 330, 810 pi. So the answer is B. Okay, let's move on to question 11. A crate that is 10 inches long, 8 inches wide, and 3 inches high is shown above. The floor and the floor walls are all 1 inch thick. So this is 1 inch thick. How many 1 inch cubical blocks can fit inside the crate, right? So again, this is asking us for the volume like any other question in this chapter. And the volume in this case is the amount of the room, right, that a 1 inch cubical block could fit. So the room in the crate box is basically a rectangular box, right? But because we have to get rid of, take into account that the floor and the floor walls are 1 inch thick, the length of the rectangle would be 10 minus 1, right? To account for the 1 inch thick walls and floors, which is 8 inches. We can do the same for the width, so just minus 2, which we got 6. And for this height, we get minus 1, right? Which means it's 2. So the volume is just we are multiplying all of these width, height, length together. So you have 48 times 2, which is 96, so the answer is B. Okay, let's move on to the final question of the chapter. The concrete staircase shown above is built from a rectangular base that is 5 meters long and 6 meters wide. The 3 steps have equal dimensions and each one of has a rise of 0.2 meters. If the density of the concrete is 130 kilograms per cubic meter, what is the mass of the concrete staircase in kilograms? So what we can notice here is that the staircases could be cut into different blocks, right? And if we cut them into different blocks, then we can calculate the volume of each of the blocks and add them together to get the volume of a staircase. So strategies like this are really important for the SAT. So we're dissecting and we're making a complex problem simpler, right? So now we notice that we have 4 rectangles, right? And then all we have to do is to calculate the volume of all of those rectangles and add them together. So the volume is, we have 5 times 2, right, times 0.2, right? Each one has a rise of 0.2, so it's 0.2. And because we're cutting them equally into 3 blocks, that's why the length is 2. And we add it to 5 times 2 times 0.4 because it rises again by 0.2. And then we do the same. So it's 0.6. And then now we add them all together. So we get 5 times 2 is 10 times 0.2 is 2 plus 4 plus 6, which will give us 12. And now we have to calculate for the mass of the concrete staircase in kilograms. So density, we're given that density is mass divided by volume. So we know that the density, now we need to find the mass. So the mass then is density times volume, right? And we know that the density is 130 kilograms. So it's 130 kilograms times 12, which will give us 1560 kilograms. So the answer to this question is B. Okay, thank you very much for watching.